Hello, everybody. Thank you guys for joining the 2020 3D Printing Materials Roundup, hosted by JuggerBot 3D. My name's Dan Fernback. I'm Vice President, one of the co-founders of JuggerBot 3D. And for the next hour, I'll have the honor of moderating a discussion about the state of additive manufacturing, with a particular focus on the future of 3D printing materials and technologies that have been or are expected to make a pretty big impact on the industry. So we're joined here today by three industry experts that are very much ingrained in the world of 3D printing materials on a day-to-day basis. I'm sure on some days more than others, more than you guys would like to be. So each of them has a pretty unique perspective to one another, and in some ways similar, in other ways different, based on their current roles and their company focus, which is something we'll touch on here in a couple minutes. The topics that we will cover today include, first and foremost, a recap of 2020, including the impact of COVID-19 on the additive manufacturing community, our current state of the industry, and where the biggest opportunities and challenges are. We'll then work into 2021 and talk about some of the trends that we expect to carry on or phase out in the new year. We'll talk about what 3D printing technologies are expected to have a strong performance in 2021, and what the additive manufacturing world should be on the lookout for in the new year. But first, I want to give a quick introduction to JuggerBot 3D and our panelists. JuggerBot 3D is located in Youngstown, Ohio, and we manufacture industrial-grade 3D printers that are uniquely capable of processing performance thermoplastics. Along with developing technologies that address the largest barriers to the industrial adoption of 3D printing, we also offer application development and support programs to our customers to ensure their success. So earlier this year, we officially launched our Tradesman Series, which is a line of large format 3D printers that are designed to process performance materials for industrial purposes. So we're talking about spare parts, nesting fixtures, molds, patterns, and even production parts. With our interdependent drive system for filament printing, or our state-of-the-art pellet extrusion technology, which is capable of printing up to 200 times faster than traditional 3D printing. All right. So we boast a lot about the breadth of materials that our printers are capable of printing. And a lot of our operators have two big questions for us. The first is, what materials can JuggerBot 3D printers run? Right? And the answer to that is simply that most filaments and pellets available on the market today are compatible with our machines, including engineering-grade thermoplastics, flexible materials, high temperature composites even. The second question that we get is, what material is best for my application, their specific application? And being that there's a number of materials available for 3D printing and that number seems to grow every single week, JuggerBot 3D is building a tool that engineers and operators can refer to in order to navigate the 3D printing material landscape. A tool we will be rolling out here before the end of the year, and something we will continue to build on for the foreseeable future, which we call the Material Shootout. So the Material Shootout will be available on our site. All you have to do is go to www.juggerbot3d.com and then scroll over to our Materials tab, which will contain resources like Spotlight pages, which feature materials that are on the market today, and Shootout pages, which provide comparisons and contrasts between various materials for easy viewing. All right. I'd like to now introduce you to our first panelist, Chad Lynn, who's the business development manager for Kimya by Armor Group. Chad is an Eagle Scout and a veteran who has experience in material recycling and plastic injection molding, and has been working in additive manufacturing since 2012, helping hundreds of companies to adopt 3D printing by supplying machines and materials across the globe. Chad's also worked on a really cool project a few years back, 3D printing props for the film Martyrs, starring Bruce Willis. All right, Chad, why don't you tell us a little bit about Kimya?
Yeah, so my path started kind of back in the machine and props and printing services, and it's led me to 3D filament manufacturer and distributor. So we manufacture our own brand of filaments. We offer 3D printing as a service. We have 60 to 70 printers to date in our lab in France and here in the United States, and we offer filament development. So thank you, Dan. Material development is a big part of what we do. So a lot of the customers we talk to maybe have a project that there's not a filament developed yet that really fits it. And I think that's where our company is very unique, because not only are we a filament manufacturer for standard brands and composite materials and high temp stuff that people are familiar with, but we are we're set up to where our labs team can do specialized materials to really, really drill down on what the specific needs of a customer are. So one of the nice flexible parts of our company is that projects don't really hit the wall with us because of something we can or can't offer. They just take another turn and we roll with it. So it really gives the end user the flexibility to decide whether they can continue on with a project and not have the limitations on what materials are out there to buy only. So that's really, I think, where we stand out. And this is a quick overview of our standard offerings that you see on the screen now. So this is what you can get to date in multiple sizes. We have in stock, but again, I do believe our labs team, where we can produce composite materials or high temp materials or standard materials that are specific to the customer needs, is also an additive benefit of Kimya.
Thank you, Chad. Our next panelist is Dr. Cora Leibig, who's the founder and CEO of Chromatic 3D Materials. Cora has a master's in chemical engineering from MIT and holds a PhD in chemical engineering from UC Santa Barbara. She's got significant experience in the chemical and plastics industry, with technology scope spanning production and process development, spending over 10 years at Fortune companies like Dow Chemical, as well as building startups in the material space. Cora, please tell us a little bit about 3D printing, Chromatic 3D Materials.
Chromatic 3D Materials, we're based in Minneapolis, and we're about 8 people. And our real mission is to take on what it takes to move 3D printing into manufacturing. And in line with that, we've also started a division in Germany, because that's where we're finding a lot of industrial applications of 3D printing into the market. Go to the next slide. So really what we're about is reimagining what is FDM. And we're looking at taking in liquid feeds, and that allows us to have a lot of versatility. By instead of having a filament extruder, by changing that out with a Viscotech extruder, then we have pump-driven printing, which means that we can go a lot faster, many times 5 to 10 times faster than filament printing. And then the other feature by going to liquid feeds that are reacting while they're being deposited is that you can get a very solid part that's strong. So this is really opening up a lot of opportunities for new materials and industrial grade printing. Next slide. We've been able to make parts that go into functional applications like a rail brake system, where we were evaluated for our flexible product versus 15 other technologies, and we were able to pass because we had a product that was flexible and strong, solid and non-porous, and it fit well. And definitely that print that you see there does not meet what usually we think about when we look at filament printing. And so it's just a good example of what's possible. Then the next slide. So what we do is we work with people like JuggerBot, people like Viscotech, and then build software components as well as chemistry components in order to make a system that works. And like Kimya, we really try to look hard at the application and their requirements to come up with a working solution.
Our final panelist is Greg Costantino, who's the new business and application development specialist at DSM Additive Manufacturing. He's responsible for developing and executing the strategy for business development in the North American region. So Greg holds a master's in polymer engineering from the University of Akron and is a wealth of experience in materials, process, and application development spanning over 25 years. Greg, please tell us a little bit about DSM Additive Manufacturing.
So just a snapshot of DSM in case many of you don't know who we are. So we're a global life sciences and material sciences company based in the southern part of the Netherlands. You can see here our overall sales about 9 billion euros with about 22,000 plus employees located throughout the world. Life science and nutritional science, things like, a lot of additives and ingredients that go into human care products, animal nutrition products, world's largest producer of vitamins, things like that. And then in materials, our performance materials cluster is dealing in a lot of different various areas, one of which is engineering materials as well as the additive manufacturing group. So one of our core to it all is on the performance material side is that we are backward integrated with very deep knowledge within material sciences. 300 plus research engineers in our science center that support our various divisions, along with all the various simulation tools and testing resources that you could imagine that make us really strong in the materials area. Talking about the additive manufacturing group specifically, we have a very strong history in photopolymers, 25 plus years of experience in the Somos brand, which is a very widely known material in the industry. But then with the formation of our additive manufacturing group 2.5, almost 3 years ago now, we are really extensively branching out onto the solids in areas of powders, filaments, and pellet printing. So we're really trying to cover the gamut of materials used in additive manufacturing across multiple technologies. In terms of the solids portfolio, we're really closely linked to our engineering materials group and leveraging their portfolio to create these products. You can see here a snapshot of what those products are, which are, the focus is nylon and polyester-based chemistries. There are some other products along with that offer some pretty unique benefits. But these are, again, the materials that we're really trying to feed off of to create materials for additive. So the focus here really is engineering grade thermoplastics to create functional materials. And, along with that, we're really driving for low volume production or production available or enabled materials that obviously meet the multitude of requirements that come from customer applications that you see, some of which are shown here. And then our way of working is shown here in this, relatively simple slide. We have a very wide network of service bureaus around the world, but we really try to tie in other really resources within the 3D printing ecosystem, such as the printer manufacturers, software providers, along with developing our own software solutions, as well as a vast network of other technologies in the industries by forming partnerships and alliances. But really the core of it all, if you see there, the nucleus is really applications. We really try to be incredibly strong and better than the competition to focus in on the application requirements and needs, and then pull in all the different resources that we have to provide the end solution, to the customer based on that application.
3D printing is a technology that is really positioned to make a huge impact on the globe. Not just because it's going to change the way that we make things, but it also has the potential to change the way we design products. It also has an opportunity to unlock new business opportunities and to change the way we as consumers buy product. But this has been a crazy year for everyone, and 3D printing is definitely not an exception from that, from the events of the year. So this has actually been one of the slowest years in terms of growth for the additive manufacturing industry in almost a decade. Still, many are very optimistic about the future growth in the space. And so a lot of the researchers are pointing to the untapped potential in industrial 3D printing solutions as a major driver of that growth. Over the next 40 minutes here, we're going to dive into a little bit of open Q&A. It's really going to center around, again, the 3D printing materials as a subset of industrial applications. But we encourage everybody to join in and really try to span the breadth of 3D printing technologies and applications here. Starting with a recap of 2020. And again, if we're going to talk 2020, I think we need to start with COVID-19 and the impact that it's had on our industry. So panelists, maybe we'll start with Greg here. Just tell us a little bit about your perspective on 3D printing's role in the response to COVID-19, and then specifically what your companies did as a reaction or response to.
From everything that we saw, the impact or that 3D printing had, I think, was really massive. I think all the other panelists, including Dan as well, saw a lot of requests out there for personal protective equipment and other things, other pieces and components to support the healthcare workers and industry. At the beginning of the crisis, I know we were personally called on by many of the major corporations, some of the automotive corporations that were involved in producing, parts and components for ventilators and things like that. So yeah, we were very deep into it. And then as a result of that, we actually formed pretty much a special team to try to link industry needs and requirements with the end users, and almost created essentially a database, or not just a database, really a user-friendly database that would allow people to go in, look for solutions they needed, and then connect them to the solution provider or the component provider. So that's one way that we really helped, the COVID response.
I mean, one of the reasons that I got into 3D printing in the first place is because I think 3D printing can really drastically improve our complex supply chains that exist in the world. And all the way from raw material creation through the finished part. And I think COVID and the crisis in our medical supply chains just really gave all of us a great example of exactly what that means and the weaknesses of that kind of. It's a very efficient supply chain, but there's problems with it, and I think all those problems became clear with COVID, and the fact that 3D printing can offer a solution to it also became clear. I mean, some of the conversations I had with medical equipment suppliers went along the lines of, look, today it's ventilators, next year's crisis, it could be dialysis equipment. So how can we use 3D printing as a way to have backup supply or local supply for hospitals? So I think it gave all of us in 3D printing a great example to point to of how 3D printing, especially if it's implemented in industrial environments, how 3D printing can help and why it's essential. And I think the other piece that we got out of this is that as a community, COVID provided an opportunity for all of us to ask the question and answer the question, how can we help? And DSM had a great tool for doing that. And there was just a lot of grassroots bubbling up opportunities for people to reach out to their communities, to their and their local environments to say, hey, here's how we can help and what we can do. And engage with the medical community at a more local level than we ever have before. So that was great.
For us, it was what was really intriguing was seeing the way the 3D printing community came together. So many companies that we viewed a year ago as maybe a competitor or someone that we had a market share with, all of a sudden we were sharing ideas and we were working together on projects, and people that we competed with helped us launch projects that helped out. And in Europe, we delivered 90,000 medical face shields. And part of that was working with companies like yours, Greg. We didn't work with your company, but companies like yours that were able to give us access to the FDA-approved designs, give us access to the places where we could get STL files quickly, give us access to the places that had a need, because making the product's one thing, figuring out who needs it's a whole nother animal. So for us, it was really some companies that we compete with and work with over the years were also willing to partner up with us and help us help people. And I would also touch on what you said, Cora, is that here in the States and in Canada, really the exposure that our supply chain had was really put out there for everyone to see. And 3D printing has a reputation of being a disruptive industry, but in this instance, we disrupted it in a good way by showing a lot of here in North America the way we were able to respond. And a lot of companies that were leaning on Asian markets now they're not going back. They're staying with local suppliers and local supplier routes because they don't want to have to worry about the lead times or the shortage of supplies or the shipping costs. So in this year, as challenging as it was, I think it brought people together as traditional methods.
So I think that's a really common theme, right? In 2020, even though obviously pandemics are bad, it gave 3D printing a chance to really shine the light on the benefits of rapid manufacturing and a rapid response. So I don't think that anybody in the space was necessarily slow from a standpoint of things to do, right? Everybody's even if you weren't necessarily on the forefront of PPE production, everybody's strategies were turned upside down. So you had to kind of adapt and overcome. At JuggerBot, we were fortunate. We're a smaller company, but we, despite the odds, managed to grow in 2020. Not as much as we would have liked to, but more so than I think a lot of other folks, and we're fortunate for that. What are you guys seeing in regards to growth, plateau, or even downsizing in our space?
One of the downsides of the pandemic is that there haven't been any conferences to get a great pulse on what's happening with our colleagues. But I can speak to where we're at. We did not downsize. When you're a startup, you have a certain amount of money to achieve a certain number of things, and those things didn't change for us. And it gave us a little bit of an opportunity to catch up and make sure that when our customers came back online, we were still suffering from the fact that customers are here today, gone tomorrow. They'll be operating for 4 weeks and then they shut down. But what we've been able to do is make sure that when they come back, we had material ready to go. Fortunately, we're a small enough team that we didn't have to do a lot of isolation. We kept the lab running. So we could continue to make the technical progress that we've made. But it definitely has not been an easy way to do business, to have customers kind of come and go and so forth. So.
I could add to that too. I think, from our perspective, again, I mentioned earlier, we deal with a pretty extensive network of service bureaus globally. We're seeing quite a few of those make further investments now in terms of buying maybe new equipment and invest in new technologies for next year, just to expand their bandwidth and be able to provide more solutions to their current customer base or grow even further. In terms of some direct customers, you do see a few maybe pulling the reins back a little bit because there isn't as much money they're going to spend. But I'd say overall, there's still a lot of very positive feedback and I think trends towards keeping investing in 3D printing and just trying to expand and push the technology, especially with generation of more data. Because really, in the end, people are talking about low volume production, and to be able to prove that, you need to essentially generate a lot of data and do a lot of testing and verification. So that is continuing. For everything we see. So there's definitely a lot of upside. Into next year.
For us, it was similar. We had growth, and we had planned for growth, both with addition of employees and addition of equipment. We were able to add, I think, 12 printers in our French lab. We added 7 or 8 here in our lab in Hebron, Kentucky, which is the Cincinnati area. So our plan for investing in ourselves continued. Nothing changed there. What did change was how we had to operate internally. So the customer face of what we do really didn't change, but what we had to do internally with people working from home, with Tradesman facility, to really get a fine-tuned idea of what their actual needs are. So you really had to have a lot more phone calls than before, more emails than before. But, I feel like we worked through it very, very well. And, as this kind of COVID hit, it changed the demand. We were kind of pushing automotive and aviation really heavy, and then COVID hit, and all of a sudden, a market that had a high demand for PEC and PEI 9085 had a demand for PETG, PLA, and PEI 1010 for ventilators. So all of a sudden, it was a big material shift, and I felt like we rolled with it well. I watched our competitors roll with it well. It was actually fun to work with some of the competition on some of these projects because they were going through the same things. So it was a very, we were able to, without changing our financial or our strategy, we just had to change the way we operate. And fortunately for us, 3D printing is an industry that is flexible. Some of the more traditional manufacturing ways are pretty set. So we were able to move.
Definitely. So the industry in whole is hopefully on the rebound, right? The world is hopefully on the rebound. And as we continue to near the end of the year, get ready for 2021, where are the biggest opportunities? Let's talk about some of the applications that you guys are seeing as low-hanging fruit or noteworthy.
For us, we've really focused down on the spare parts industry. So one of our successes this year is that we got the approval on the to move ahead with the German rail service part. And what we're learning, by focusing in on industrial grade printing, we've been able to find a number of equipment operators in a number of different sectors, whether it be tractors and ag or rail or just industrial equipment. We're finding a lot of opportunities for providing spare parts. And we're hearing a lot from customers about demand that's in the sweet spot for 3D printing, sort of 100 to 1,000 parts per year. And we're seeing that by focusing in on some of these libraries, we can kind of get a little bit of a coalescence of some of that demand, so we can focus our efforts on getting things qualified and establish some of that steady 3D printing production. So that's been a case study for us that's been really interesting. It's been interesting to see when we look at these companies that are operating equipment, to see some of that consolidated demand that really can be a good success for 3D printing and get us out of the prototyping kind of business model.
Can you dive into a little bit? You said spare parts specifically. If you can you tell us what kind of parts are they? Or rather, what kind of traditional manufacturing process would have been used to make those parts?
So the parts are coming from, it's all different technologies. They can be plastic, they can be rubber, they can be metal. And, we're hearing about companies that maintain warehouses that have 600,000 different SKUs of parts that they're trying to maintain over, 10 to 20 years of service life or more. And so there's really an opportunity, we're definitely diving in and looking at how our materials, focusing on the flexible range can play a role there. But there's really opportunity for all 3D printing technologies in kind of this spare part warehousing focus. And there's a number of companies who've looked at it. But I think looking at how we can kind of join forces a little bit as we're going through the libraries looking for elastomeric parts and identifying places where other technologies can play a role, I think there's a real opportunity for 3D printing to transform how warehousing gets done. And it really provides that opportunity for true just-in-time delivery and digital warehousing that can eliminate a lot of the inefficiencies and wait times associated with spare parts.
Thank you, Chad. Please go ahead.
Well, I was going to piggyback what you said, and Greg, you touched on it earlier. You were seeing in the molding and die and tooling industry where the original concept of 3D printing is, how do I print this part? Where now the designers are thinking now, well, wait a minute, the end part is a flexible material. How do I print this mold, especially if I only need 100 shots or if I only need 200 shots? And so the thought of, I have this part, let me print it, has changed to, oh, wait, I have this $35,000 mold. Well, I can print it for $1,200. Okay, well, I don't need 50 shots. Let's try it. So you're starting to see the mold industry really think about this in a whole. We mold parts. I need 100 TPU parts, and I can 3D print the mold for 100 shots for a few $100. They're using it now more as a supplement to what they already do, and not as a replacement. And that's really, especially with the new materials that are out in the markets, the high temp materials, the customers have a better understanding of post-processing, because if the TPU part comes out a little bit rough, they're going to do some post-processing on the finished molded part. Or they don't mind that because they print their mold and they do post-processing on the mold to make a smooth mold. So I've seen it both ways, where the company's like, hey, a rough mold's okay, we'll do some work on the 50 parts we shoot. Or don't worry about the mold, because we'll sand it down and we'll coat it and we'll make it real nice. So the idea of, I have this part and I got to print this part is really changed to, I know how to make this part and I can print the tools to make it.
if I could add on to that, I mean, and we're seeing it in both of those areas. So from what Cora said, the spare parts market is definitely an area of interest, as well as tooling. And in terms of types of technologies, I mean, we see it anywhere from the photopolymer side to filament printing to pellet printing, so almost across the board in terms of types of technologies. I think more on the innovation side, though, we're seeing, I think, a lot of customers that want to do, again, keeping in mind series production, really taking a look at things like electronics applications or other areas within, and that could be consumer or automotive electronics, consumer-based applications, whether it be in oil and gas, furniture. So it's quite a gamut where people are definitely taking a closer look at some of these technologies to be able to, and the material development is obviously a big side of it, right? Where getting the right materials, more advanced materials with the right technology gives them a lot of capability.
Yeah, and it's time and cost. I mean, the time it takes, and I'm harping on the molding industry a little bit, but the time it takes to create a traditional mold today versus the time it takes to print one is astronomically different. The cost to make a traditional mold today versus the cost to print one is astronomically different. And 3D printing, because the costs are so low, leaves room for mistakes. If you make a mistake, it's not a $100,000 mistake now. Now it's a $6,000 mistake or a $2,000 mistake, whereas some molds, how complex they can be a $20,000, $30,000, $40,000, $50,000 mistake, and you got to start over. So with 3D printing, you never want mistakes, but because the costs are down, it leaves room for them.
Right. Mistakes happen, whether we want them or not, sometimes.
Right.
Jeff?
I have two questions coming in. One from a guy that I think might know a little bit about this subject. His name is Zach. But yeah. So are there any new strategies from the material companies going forward? Are they taking considerations from the users with respect to applications and altering their chemistries to accommodate the available technologies?
There is definitely the continued strong push for developing new chemistries. And again, that could be across the board with the photopolymers as well as on the solid side. And again, though, as I mentioned at the beginning in my intro, really the core to that, though, is application driven. So as you see more and more, I call it advanced applications, or again, applications that are being sought after for low volume production or production scenarios, that's where the demand for more functional materials is greater, right? So with higher mechanical properties, higher thermal performance, et cetera. So it's definitely, again, application driven, but yeah, there's definitely a continued push to develop, further technologies. But I guess along with that, and this is where I guess companies like Cora come in, fantastically, as well as with Chad's, with some of the unique materials that you offer. I think we start to see a lot of applications where they combine technologies. So, for example, you could keep it simple. Like, for example, filament print a toothbrush and then put on the soft touch grip to it with Cora's material. But then think about more complex applications within other industries that need something like that. We even see, I guess personally, I've come across various applications where you might even go down the line and talk about hybrid or composite technologies that maybe you need to 3D print a combination of even metal and polymer, or more advanced, filled materials like in the area of pellet printing that are again composite materials because you need that, very high modulus and stiffness. And I guess an example that we're working on directly in that area is 3D printing of bridges and other structural components for some companies we're working with in the Netherlands. There's a massive effort there driven by the government mandates to replace, I guess, old out-of-dated bridges with 3D printed bridges. But they're also looking at other things in the construction industry, like building facades, tunnels, things like that. So that's really where the design and software development comes into play. So you're really at the very, I guess I'll call it pinnacle of advanced performance there, because that's many, many years of performance, in the environment. That's where I think all that comes into play.
Okay, and we do have another question from the audience. What do you see as the primary limiting factors for low-run manufacturing of final use parts using high-speed FDM?
we're really limited by the lack of design for additive know-how broadly within companies. I think we have a lot of corporations that have 3D printing departments, but until additive is sort of a part of how engineering is done, I think that's a major limitation. 3D printing companies are having to do the heavy lift of doing a lot of application development. That's limited by how much our customers allow us in to innovate with them. And I mean, obviously, we have a limited property set compared to the way stuff gets made, there's like thousands of different processes, and there are different ways that 3D printing can replace or offset or change. And the same, we have a limited set in terms of materials also. So you definitely need the materials to be up to snuff, and you need the speeds to be up to snuff. But fundamentally, you need to have that insight on the ground floor on how to apply the set of Legos that we have to solve a problem.
Everybody's talking about metal printing and how expensive it was and if it was ever going to take off, and talking about filament printing and how the materials were kind of basic and what new and great materials are going to come out. And I remember going through it thinking, well, we can make any material. We can come up with any kind of manufacturing process. The bigger limitation is getting design files that were thought up around traditional manufacturing. I can't tell you how many STL files I've looked at with open contours and floating objects and things that make sense in a CAD simulation file, but make no sense when you drop them into printing slice software. So, I agree with you there. And it's not that it's a wall we can't get over. It's just that the knowledge for design knowledge it's not widespread. So design knowledge is, if you go to most universities, get your mechanical engineering degree, you're going to get taught to design based to traditional manufacturing methods of CNC and wax molding and casting and things like that. So there are a lot of things you can do on the design side that'll make the print life so much easier. And it'll increase production time. It can increase or reduce mistakes and bad prints and things like that. And I don't want to get too detailed, but small things like building bridges so you don't have to use more support material and things like that. Building a raft so it doesn't stick to the build tray and you can swap jobs out quicker. There's a lot of design things you can do if you understand the process. And I agree with you 100%, Cora, that today's design teams, to no fault of their own, are taught traditional design methods, and their thoughts are designing to the way things are manufactured today. So this new manufacturing process kind of pushes the designer to challenge themselves a little bit.
Speaking on that note, where there's an emphasis placed on designers understanding how a 3D printed part is not only going to be made, but how it performs. If speaking from your guys' perspective, where you're developing materials or developing even maybe custom materials for a specific application, what are you guys looking for as far as application intel, or how can that intel help you guys to better optimize the materials you're offering to the customer?
I usually look for what is critical for performance. So for example, many times people will show a diagram that's made for injection molding with kind of a really low tolerance on dimensions, but they don't actually need necessarily that kind of tolerance. And so really knowing what features really require the dimensions and the dimension tolerance that they're talking about. Because usually with 3D printing, we can deliver that level of tolerance in specific locations, or, just like injection molding can, right? So injection molding has weaknesses also. It's just that people know how to design around it. And so really understanding how the part is used is critical, as well as, sometimes there'll be a shape that's drawn, and it's drawn in such a way that it'd be easy for injection molding, where 3D printing, you can avoid a whole lot of, overhangs and stuff like that if you just changed how it pivoted. But you need the user to know, look, it has to fit here and here, and then you can design for it.
So it's really like a holistic approach.
Yeah, no, for sure. Everything that Cora said. And then obviously if available, any product specifications, because obviously depending on the industry you're working with, that could be available to you, which, outlines, maybe some of the details on how they're going to test. But yeah, narrowing down to the basics is essential.
Yeah, and some of the and you hit it again, Cora. You're showing off that degree. Some of the applications that customers need, like we had a customer in the past that gave me this high tolerance design. It's got these tight contours or tight geometries they're trying to hold. And when I got to talking to them, it didn't matter. Well, they needed it just to be chemical resistant. That was it. Like, oh my goodness, well, we can make this so much easier if all you need is chemical resistance. So let's choose this material. I think we chose polycarb at the time. Choose polycarb and let's loosen up some of the restrictions on these tolerances and let's go, because we can achieve it by picking the right material, and so but again, it's traditional design. You're thinking of tolerances and injection molding and some of the curvatures that injection molding holds, where in the end, it was really just a chemical resistance was what we needed. And some of the robotic arm industry, end of arm tooling, lightweighting is what they need. So, getting hung up on the design when needs. So that's really the piece. I agree with you, Cora. It's getting to what is the actual need. And sometimes you can give up a handful of things if you address that need.
The actual definition for sure is something that we need to constantly work towards for application development, if you will. Now we have about, we're kind of running long here. So I'd like to start talking about what 2021 looks like, starting with, getting your guys' perspective on what are the key industry trends that are driving or prohibiting activity in the space.
You got to think where we're coming from. We're a filaments manufacturer. So we're looking to push filaments. And so for 2021 for us is not just on the industrial side, but we also work a lot with the hobbyists and the in-home printers. And what we're seeing now, and I spoke to you the other day about it, Dan, is you're seeing people buying 3D printers at a record pace that you've never seen before. I'm talking about just actual people, not companies and industries. So what it's doing is it's getting people more focused on the design side, how printing works. You're starting to get that knowledge to the end user. So the customer base is getting educated on their own. I mean, I was looking at an Amazon thing yesterday where they sold 1,000 of this little tiny printer in one day. So that's 1,000 kids that are going to understand 3D printing, and will understand how to design for it if they choose that path. So I see that. But the other thing we're seeing for us for 2021 specifically is the demand for more high temp materials and more chemical resistant materials. One of the materials we're looking to release in 2021, hopefully Q2, maybe Q1, Q2, is high density polyethylene, something that's more comparable to a fractional melt. So I think that's going to have a real appeal on the market. And because of the ease, ethylene's not a high temp material, so it's easy to print, it's easy to work with. It's low cost if you make mistakes, but it's it's a material that's on high demand within traditional manufacturing. If you talk to most people working in the mold industry, they're working with ethylene. So we're excited about that. It's not officially released, but for 2021, for us, that's going to be a good product to put out.
Yeah, and I mean, maybe to build on that a little bit, I think that it definitely follows suit for us. I mean, I think and again, it may be irrespective of material technology. So for photopolymers, I think, you still see people requesting even recently, durability in like UV resistance, exterior type applications, maybe along with higher temperature. Our development in some of the other solids-based products is going to continue along, and the theme is the same as what Chad just said. Maybe, I guess, from our perspective, a pretty exciting thing for us is our business, as well as another piece of DSM, was acquired by Covestro. And Covestro has a presence in additive in different chemistries than what we have. So that's just going to, I think, strengthen our portfolio and offering out there into the market. So that's definitely a big thing for us, for sure.
I think for us, we're just continuing our progress with getting traction in the market and getting approvals. Pretty excited that we've got a what we're calling Chroma Motive, a new grade coming out that's right now the initial results show that it's about 80% tougher than EPU 40 at the same hardness level. And so we're just getting the suite of tests done to show really where its performance is at. But we're really excited about bringing to market kind of the toughest flexible material available. But I think the most important thing is really just getting traction with this spare parts design and showing the demand for low volume production.
Cora, and if I can speak a little, I'm excited on a past life because what you guys are doing over there, 8 years ago, even really is unthinkable. When you looked at UV printing, printing with polyjet, SLS processing was a nightmare. The holding up to UV light, holding up to heat, holding up to chemicals. If you guys are producing high, nice curvature contour parts that are holding up to heat and pressure and chemicals, and you're doing it through FDM technology, which is actually really exciting, I think you guys are onto something pretty big, because that was always the drawback. No, thank you. It was always the drawback was like, well, if you go FDM, it's not pretty, but if you go polyjet, it's not strong. And it looks like you've married the two. So that's pretty exciting.
We're trying every day.
So let's do a lightning round, if you will, right? We're going to have maybe 3 questions here and just one answer per person, starting with something that overlaps with a question that came from Thomas Black, which is, will pellet extrusion or FGF replace filament methods because it skips an expensive processing step of making a fine filament? And if so, how far out is that in terms of years or quarters? Greg, why don't you handle that one?
I don't think it'll completely replace it. I think, again, application driven. I think there's various applications where pellet printing is definitely a better solution. But when you get into smaller, more intricate components, I think filament printing, along with a lot of the different advanced materials that are available there, might be a better fit. So I don't think it'll completely replace it.
Can you talk to a little bit about the bigger challenges in adopting FGF printing?
Bigger challenges. I think, obviously, if you take a broad brush look at that market space, it's still very much an emerging technology. There's a few players in it, companies comparable to yours that offer that size printer. And then if you go large scale, it's even less. I still think a lot of people are dipping their toe in the water, shall we say. Again, asking for a lot of data and information, show me is really what it is. But I think there's going to be a lot of further ground made with some other programs out there, especially. I think, tooling will continue because that's where it's probably established a foothold already, and will continue, probably to expand in that. But I think as some of these other areas expand, not only in material development, but software and design and just being able to print larger things, will expand into other markets and enable other applications.
Chad, do you want to add something there?
Yeah, it was exactly what you just said. I think the pellet market it's going to grow. The missing piece, much like design engineers understanding how to design for 3D printing, is the know-how on the operator side of how to operate pellet-driven machines. There's a little bit more that goes into operating a pellet process, and I think that's the piece. And people that nail it love it. They figure it out and they run with it. People that are kind of still in the learning curve of it are a little bit intimidated by it. And what I've seen is that companies running with pellet will run in standard materials like ABS and maybe polycarb because they're scared of mistake. They don't want the mistake to cost so much, but they get shied away from a PEI or an Ultim or a PEC because the material prices start to go up. So maybe I'm missing, but I think if we get the people educated on how the pellet process works, I think you'll see that drive more. Right now, it just intimidates some, not all. The ones that figure it out are having great success.
I really love pellet extrusion. I think it really opens up. There's so many, when we did initial voice of customer starting Chromatic, I thought one customer put it exactly right. They said, look, when I'm picking a pellet, I've got 10,000 materials to choose from. When I'm doing 3D printing, it's 10. And maybe 3D printing's up to 50, but it's not 10,000. And I think pellet extrusion really opens up that possibility. There's technical problems with every one of these technologies, right, that need to get solved. And I think when you have a rapidly growing market like we do in 3D printing, where it's growing 25% a year, or maybe it's 20 and it's a bad year, right? But if we're in that 20 to 30% range, we're all growing and we're not really competing against each other. Our jobs are really to help our customers adopt the right technology for what they're trying to do. All of our technologies, however they are today, are going to look totally different and have different capabilities in 10 years. They're going to be faster. They're going to be higher resolution. All that stuff is just going to rapidly improve. And so we really just need to be thinking about, if a customer has the right application for doing 3D printing, helping them figure out the right way to do it, given their application needs.
We talked a lot about the effects of COVID and where we are right now in 2020, as well as a glance forward for some of the technical challenges and business challenges that need to be overcome in 2021, where we see opportunity, and really what to be on the lookout for in the additive manufacturing space. So real quick, I want to give Chad, Cora, and Greg a chance just to tell people where they can contact you, where they can find you if they have questions, follow up there afterwards, which we'll also include on a follow-up email to the registration here.
So you can contact us at chromatic3dmaterials.com or c3dmaterials.com. The contact us will go straight to my inbox. We'll make sure it goes to the right place. Definitely, we are looking forward to hearing about what people are trying to do with 3D printing. It's a really exciting field. For us, I mentioned Chroma Motive. I'm also really excited about the continuing improvements we're making in our software that really expands the geometries that we can access with our printing. So that's what I'm looking forward to in 2021.
Yep. Yeah. For me, obviously, you can find me on LinkedIn or greg.costantino@dsm.com, which I'm sure Dan will blast that out to everybody. Thank you.
Chad, I think we're hearing you a little better. You want to give it another go?
Yeah, likewise. You can find me on LinkedIn. We're kimya.fr. You can go to the contact link that'll get to our team. It'll get back to me. And to touch on some of the challenges that you had asked about for us, I think it's going to be, for us, it's educating our base in the high temp space, because that's an area where there's annealing processes, post-processing, and people can be intimidated by that. So, get are processed and printed and how to work with them with what we are. That's our biggest challenge for 2021, is really getting that knowledge to the customers so they understand how our materials can be best used.
There's a really good question about the future of color in 3D printing. So would you like to take a stab at that? Well, obviously, we'll package this into the recording, even though others may have to leave, but thoughts on the use of color and in 3D printing?
At least from our perspective, with some of the different technologies out there, or not just technologies, but applications, there's definitely a need for multiple, colors besides black or white. Some of the filaments we have are available in other colors, but we've made some efforts on the development side to even look at different color materials to print with, but then also technologies, post-processing, coloring, dyeing to make coloring available. So I think still definitely, in the development stage to try to get answers there to print in color.
I think color is one of the reasons why extrusion printing pellet extrusion is really exciting. Our technology is also really amenable to adding color. I think powders also offer a lot of opportunity for color. So there's a lot of options. And again, it comes back to, what do you need it for? I know for our technology, one of the things that we need to make a few more advances on is integrating with our colorant suppliers so that we can take advantage of what they've already got in-house for doing color matching. But I think there's a lot of opportunities for color and And a lot of the advancements that are happening are taking us towards more color.
Yeah, I mean, for us, we have the labs team, so we have an advantage that we can make any color a customer needs. But color, like everything else, is limited by the technology. So in the filament space, if you wanted to print in 3 or 4 different colors, you either have to pause and switch materials, or you need a printer with 3 or 4 extruders. And right now, there are printers out there with 3 and 4 extruders, so you can print multiple colors. But if you switch technologies and go to a PolyJet or to a SLA or an SLS, you can print parts that are tie-dye, But then you have to ask yourself, do you need it to be strong? Do you need it to be chemical resistant? And sometimes you have to give up one for the other. So your tie-dye part might not last out in the hot sun, but you got tie-dye, right? Where your FDM part, you're stuck with 2 or 3 colors, but it'll survive a hot day or engine oil. So colors are out there and you can get them, you can achieve it, and you can achieve tight tolerances. But in the end, application tends to drive it. So it's going to be what you need it to do.
Yeah, application is the key thing here, guys. So we're heading over time now. I thank you guys all for joining, and thanks to the audience for attending today. Thanks to panelists, Chad, Cora, Greg. Really appreciate your guys' time. Thank you to DSM Additive Manufacturing, Chromatic 3D Materials, and Kimya. And then also thank you to Jeff for hosting, and the Business Journal for working with us at JuggerBot 3D. For more, check us out at juggerbot3d.com. Remember to check out the Material Shootout. We'll talk to you guys soon.
Thanks for watching the video. Be sure to like, subscribe, and hit that little bell for notifications. And also make sure to connect with us on Twitter, Facebook, and LinkedIn. For all of your business news, visit businessjournaldaily.com. For all of your arts and entertainment news, go to afterhoursyoungstown.com.